All right, I thought I would let's go here real quick. Let's take a look at what we're talking about here. All right, I thought I would look at a few at problems 9, 10, and 11 real fast. Give you some helpful hints. All right, how to solve them. So let's set up the equations that we're going to use for these. All right, and I want to get this down to about 2 5-minute videos. All right, so the equation. The hell is that? Oh, that's my push the wrong thing. There we go. All right. Now, we're looking at everything's in the y-axis here for the most part. All right. So we're looking at y final is equal to y initial plus or minus, depending on the velocity of v naught in the y direction times t minus 1/2 times 9.8 t squared, which we write this way as y final is equal to y initial plus v naught y times t minus 4.9 t squared. Okay? Now, sometimes you might have to solve a quadratic, okay, on a homework problem. I try and avoid them a little bit on exams, but you know it's still a quadratic equation, and you can do it. You're totally capable of doing a quadratic equation. So here's what we do and we're going to also take advantage of this equation. V final y is equal to v naught y. So these are the notes for homework help. Number 1. All right, I'll probably do this throughout the semester. So v naught y minus gt. All right, so I think we did the dolphin in class, but let's take a look at what the dolphin, when he's coming down. All right, how high does his body rise out of the water? In meters, we figured that out by basically using this equation here. This one works. Makes it nice and easy. Oh, did we need to find out how high he went as he came out of the water? And we did that in class. How high does his body rise when he comes up out of the water? Well, we could use this to find that. We could use this equation. I think we did average speed, right? And so we found the average speed to find the time. You could also use this equation to find the time, and then just plug that into here, okay, and figure out how high he went, where y naught is equal to 0, where y naught would be equal to 0. V naught y is whatever he burst down the water with, and then solve, because at max height, here's a little hint, max height, v final y is equal to 0. Now, the next question on that is, how long was the dolphin in the air? How long is the dolphin in the air in seconds? Well, we found the time. We did that first. And another way to do this problem, I mean, I can find out the time he was in, total time he's in the air in seconds real quickly by using this equation, by using this guy again, because I know for the total time he came up at on my problem. What was his speed? My problem, it was 12 meters per second. Okay, what's the total time? We want to know that. So here we go. V naught in the y direction is 12 meters per second. Y initial is equal to 0. And total time, we could also say y final is equal to 0. Let's use this quadratic equation thing. Total time is also equal to 0. So we wind up with this. We wind up with 0 is equal to 0 plus 12 times t, which I don't know, minus 4.9 t squared. Okay? That's what I get. And you might be going, well, that's a quadratic. This is an easy quadratic. Why? Because it's equal to this. You don't have a c term here. So you can just factor out so you got 0 is equal to 12t minus 4.9t squared. Factor out t. You've got 12 minus 4.9t. Now, both these equal, this t is when it is equal to 0 when it first starts, okay? And then this term is for when y final it's actually going, all right? And this will give us our total time that it was in the air, okay? So we'll solve for this guy. So take 12 minus 4.9t is equal to 0. That solves us for, this is for y initial, and this is for y final, okay? And we wind up with 4.9t equals 12, and you divide that. You take 12 divided by 4.9, boom. And I got 2.45. So that's one way to solve it. The other way to solve it, the second way to solve it would be to use this equation, this guy, where you'd go, okay, well, minus 12s is equal to, or 12 meters per second, is equal to positive 12 meters per second minus 9.8 times t. All right? And I wind up with negative 24 meters per second divided by negative 9.8 is equal to t. And boy, I hope it's equal to that. It looks like it's going to be pretty darn close. Guess what? 2.45 seconds. Again, the beauty of physics and why it's also hard. All right? So that's that one. We'll do